Hi, I'm Claire Ligori. I'm a principal engineer at AWS in the AWS Containers team. And today I'm here to talk about hands-off automating continuous delivery pipelines at Amazon. I've been at Amazon for about 6 years now. And before I came to Amazon, my entire experience with deployments was very manual, not automated at all. And deployments were these very nerve-wracking experiences for me. I would try to figure out what change I was supposed to be deploying manually. I would frantically look at logs and metrics after deploying, trying to figure out if I'd broken anything. And then I would try to figure out, was I supposed to roll back? Should I roll back? How do I roll back? And when I joined Amazon, I noticed that the other developers on my team didn't really have that same anxiety about deployments that I did joining Amazon. They wrote their code changes, they got them code reviewed, they pushed them into the source code repository, and then they trusted their team pipeline to take care of the rest of safely and automatically deploying that change to production. And so I came to love the way that we do continuous delivery and the way that it gives us such great developer productivity because deployments are hands-off for us. This is a typical continuous delivery pipeline for an AWS service team. And when I joined Amazon, I found these to be very overwhelming. There's so many steps. It looks so complex. You probably can't read most of the text on the screen. There's so much going on in this pipeline. But when I started to learn how to set up one of these pipelines, I learned that there's really only a few core deployment practices going on here that Amazon has iterated on over time that have arrived at what our pipelines look like today. So today in this session, what I'm going to do is take you through a few of those core deployment practices that contribute to how we do continuous delivery at Amazon. So first, I'll talk about how we balance safety and speed in our pipelines. I'll talk about automatically rolling back in our pipelines. And I'll also talk about our approach to automating pre-production testing in our pipelines. Let's first look at balancing safety and speed. So production deployments always carry some amount of risk of causing impact in production, no matter how well tested they are. But we need to balance safety of our deployments with speed of getting those changes out to customers in production. We want to get our changes out into the hands of customers as soon as possible. So we need to balance these things, and there are a couple of different approaches we could take. On one end of the spectrum, we could deploy as fast as possible, deploy our changes out in minutes to all of our customers. And that would get our changes out there really quickly, but it would put us at a really high risk of impacting many, many customers in production. And then at the other end of the spectrum, we could deploy as slowly as possible, maybe even deploying out to one customer workload at a time. But that could take weeks or even months, even though it would be as small a risk as possible of impacting many customers. So of course we want to achieve both speed and safety, and our approach at Amazon is to balance these two in the way that we set up our pipelines. So the way that we talk about our approach to balancing safety and speed is to deploy small at first and then more broadly. So changes going out to production deploy to really small amounts of production capacity at first, really slowly, and then over time we bring those changes out to larger amounts of our production capacity and deploy faster. So let's look at how we actually implement this deployment practice in our pipelines. So this is a typical pipeline, very simple: source, build, test stage, and then our production stage. And the first thing that we do at Amazon to limit the scope of a potential impact from a deployment is to have individual microservice pipelines. So this pipeline might be deploying a code change or an infrastructure change, but it's only impacting a specific microservice within our system. And so the scope of impact is limited to the customer workloads that are being served by this microservice. But that single production stage is, of course, high risk for impacting many customers with a single deployment. So the first thing that we do to break up that deployment and minimize risk is to add what we call a one-box stage. So one box used to literally mean one virtual machine or an EC2 instance. And of course, over time, it's also come to mean one container or a small percentage of Lambda function invocations. But generally, it means that we deploy to a very small unit of our production capacity at first and ensure that it's not causing impact to those specific requests or workloads that are being served by that one box. The one box is a really small percentage of overall capacity. In this example here, it's only up to 10% of our overall capacity. And the one box isn't really special other than we deployed there first. It's behind the same load balancer as the rest of our production capacity. So in this example, it's serving 10% of production requests. But now we have this one box doing a very small scoped, small risk deployment. But we've got this 90% of the rested capacity that could be a high risk for deploying there all at once. So we further break down these production deployments with rolling deployments. What rolling deployments do is incrementally deploy out a new change to production until it's made its way all the way through the production capacity. So in this example, it only took out 33% of the rested production capacity to deploy that new change out to production. So we've scoped down the risk of potential impact as we move that change out into more and more production capacity. But of course, 33% of all of the production capacity could still be high risk, still a high scale. So we need to further break down this one box and production deployment into smaller deployments. So the first way that we do that is to split it into regional deployments so that we're only ever impacting and deploying a change to one region at a time. So each region in this case gets its own one box and its own prod stage. So the very first deployment to one box in one region is a very, very small percentage of our overall production capacity, and we limit the risk of impact. But even at the regional level, it could be still a really high risk of impacting many customers at high scale. So we need to even further break this down into zonal deployments. So in this case, we break down each region into its availability zones, and each availability zone in that region gets its own one box and own prod stage. So the very first deployment to production is only a single box in a single zone. So it's a much smaller percentage of that overall potential impact. But this is the point at which we need to balance safety and speed. If we put all of our 70 plus availability zones with one box stages and prod stages in the pipeline sequentially like this, that could take weeks or even months to get a change out to production. So we need to bring back some speed into our pipelines. The way that we do that is a strategy that we call deployment waves. So deployment waves are a way for us to start parallelizing deployments in the pipeline once we gain some confidence that that change is not going to impact customers in production. So in this example, I have a 5-wave production pipeline. And in the first 2 waves, I'm still scoping those deployments very small, only deploying out to one region at a time, and within those regions, only one zone at a time. And so I'm able to build confidence with very small scope deployments in production at first, and then deploy out more broadly. So wave 3 in this example deploys out to 3 regions in parallel, and then more as we get into wave 4 and wave 5 as we're building confidence in this change. But one of the things that I found brings even more speed to Amazon pipelines is that production is not a single atomic stage in an Amazon pipeline. I used to think of deploying to production as one change goes in, and then another change can't be deployed to production until that change is successfully deployed. But at Amazon, waves and stages in the pipeline are actually independent deployments. And each of these deployments could be going on in parallel with other stages in the pipeline, each deploying different changes that are moving through the pipeline and getting promoted from one stage to the next. So in this example, I have up to 5 changes flowing through production, deploying out to all these regions and availability zones. And as soon as, for example, wave 1 is done deploying successfully version 5, which might be a git commit from my source code repository, it promotes it into wave 2, and now version 6 can start moving into wave 1 while wave 2 is deploying v5. So I can have a lot of changes rolling through my pipeline at any one time. Let's look at what a wave looks like in the pipeline in detail. So this wave 3 is deploying out to regions C, D, and E in parallel. And in fact, I have multiple stages within this wave in the pipeline. So of course I need to break this down into zonal and one-box deployments so that each individual deployment that's happening in that region is still small scope and small risk, but I'm able to parallelize those deployments. So as an example here, I have all of the zonal and one-box deployments for region C across the top, region D in the middle, and then region E along the bottom. And so the first thing that happens in this wave is that we deploy to one box in one zone for all of the regions in parallel, and then start moving it through those regions in parallel. So we're never touching with one new change any more than one availability zone in that region, but we're able to actually parallelize these deployments and keep different changes moving through that pipeline. So here, because these are independent stages, I can actually have 6 different changes moving through this one wave because they're all independent parallel stages in the pipeline. So if I had 6 steps in each wave and 5 waves in each pipeline, I could have up to 30 changes all deploying and progressing through production in parallel, promoting one to the other stage. So at Amazon, the way that we balance safety and speed is by first limiting the scope of impact of a potential impact in deployment in production, and doing that through individual microservice pipelines, one-box deployments, rolling deployments, regional and zonal deployments, and that really reduces the risk of impact of each individual deployment. But then we bring back some of that speed and balance the safety with speed by gaining confidence through deployment waves. Let's now look at rolling back automatically in Amazon pipelines. When I used to do manual deployments before I joined Amazon, this was a very familiar graph that I would sort of stare at during a deployment. Very spiky latency graph, and I would sit there and try to figure out, is this spike because of my change? Is it a normal spike? Are there more spikes coming? Should I roll back now or should I wait? And at Amazon, we don't want to sit and have to stare at the dashboard every time we do deployments. We want deployments to be hands-off. And so at Amazon, we let the pipelines watch the metrics so that developers don't have to. And the way that we do that is through setting automatic metric thresholds for the pipeline. So for any kind of metric that we think we might want to automatically roll back on, the team will set a threshold for what's considered acceptable for that metric. So in this case, I have a threshold for my latency, and if at any time during the deployment that threshold gets breached by that metric, the pipeline will automatically roll back my change. And often this will also engage the on-call engineer once that metric has breached that threshold. But often the pipeline has already started rolling back the change and we're already on our way to recovery. The pipeline watches any kind of metric you can think of. If there's a metric, we should set an automatic rollback threshold on it. So things like latency, request success rates, system metrics like CPU and disk and memory are all watched by the pipeline. And if any one of those goes into alarm, then the pipeline will automatically roll back. The pipeline will also look at different aggregation levels for these metrics. So it might look at it at the regional level as well as the zonal level for each of those zonal deployments. And then it will also look at it at a one-box level for those one-box deployments. But we don't just look at just the metrics coming out of the component that's currently being deployed by the pipeline. One of the things we found is that often when you deploy to an individual component, the impact from that change may not show up in that component's metrics. So for example, in this multi-tier application here, I have monitoring canaries calling the front end, which calls the back end, which calls the database. And for example, if I push a breaking API change to the back end metrics may not actually show any problems. They may show just successful requests coming in. But it's the front end metrics that are trying to call that API that are going to show the impact of that change. And so the pipelines look at a larger part of the system, a larger set of components that could be impacted by this deployment. And that's called aggregate rollback alarms that we configure in these pipelines to watch the metrics from any of these related upstream and downstream dependencies, so that if any one of these components goes into alarm, any of these components' pipelines will automatically roll back. Another thing that we've seen as we've done more and more deployments is often the impact from a deployment doesn't always show up during the deployment. So for example, if the deployment got kicked off first thing in the morning and there just didn't happen to be much traffic at that time, but then later in the day after the deployment is done, customer requests ramp up and all of a sudden we start to see impact from this change. At that point, the change may have been promoted in the pipeline to multiple zones or even multiple regions with a potential for a much broader impact to more customers. And so we use a strategy that we call bake time for deployments. So bake time is a period of time after that deployment that the pipeline is going to continue to monitor those metrics thresholds. And if at any point during that bake time, the spike happens during that bake time, the pipeline is going to automatically roll back. And during that time, the change is not actually going to be promoted to the next stage of the pipeline. It's going to be held there until the pipeline sees that the bake time is successful. So let's look at auto rollback in action. What actually happens in the pipeline when we hit one of these thresholds and the pipeline automatically rolls back? So in this example, I have a 5-wave pipeline, and I have a couple of changes that are rolling through the pipeline. I have V1 in blue, which has made it all the way through the pipeline out to wave 5. And I have a second change, V2 in purple, that's made it to wave 4. And at this point, region I's metrics go into alarm. So the pipeline automatically rolls back only region I, because only region I went into alarm. Nothing else has shown impact in the metrics. So at this point, the on-call engineer gets engaged and they have a choice to make. They can either determine that this rollback was unrelated to the deployment, just happened to have a metric spike at that time due to some other issue going on, and they can retry that deployment and keep that purple V2 change rolling through the pipeline. Or they can determine that that change could have impacted any region, just happened to only show up in region I. And in the pipeline tool, they can trigger a rollback for all of the stages previous and get everything back to that V1 change. They can also determine that only region I would be impacted by this change, maybe because of a particular configuration in region I. And they can choose to just let the pipeline sit in this state and start rolling out a new V3 fix that they pushed into the source code repository, let that go through the pipeline. So because the pipeline can automatically roll back a change at any point as it's propagating through the pipeline, it's important for us to design changes for automatic rollback. It always needs to be safe to roll back a deployment in production. So we follow 2 guidelines for this. One is, where at all possible, our priority is to design changes to be backward compatible. So APIs, for example, always have new fields are optional when you add them to the API so that we can roll back that change automatically in the pipeline. But sometimes it's just not possible to not make a backwards incompatible change, but we still need to be able to roll back those changes. So we split these changes into what we call a two-phase deployment, into multiple individually backward compatible changes. The way that this works is we split up this change into a few different unique code changes. So the first code change that a developer would write up, get code reviewed, and push into the source code repository and let go out the pipeline is the prepare change. So this is where logic is added to read that new format that we're going to be moving to. For example, if we're changing the data format for an SQS queue, and at this point, the prepare deployment can always be automatically rolled back in the pipeline because we're not yet writing that new format. So we're only exercising the change for reading the old format. At this point, there's a little bit of manual coordination. The developer needs to make sure that that prepare change has moved all the way through the pipeline, and we're confident that we're not going to need to roll it back anymore. And then they can start to get code review and push into the source code repository the activate change. So the activate change is where we add the logic to actually start writing that new format. So at this point, we start exercising that code and the prepare change to start reading the new format as well. But that activate change can also be automatically rolled back because we still have the logic in the code to read the old format. And we have the code there to read the new format. So we can read either format when we roll back. So finally, again, a little bit of manual coordination to make sure that that change has gone all the way through. And if possible, we're no longer writing in that old format. We've completed a database migration or drained that SQS queue of any old messages. And at this point, we can do an optional cleanup. We don't always do this. It's not always possible to ensure we're not going to need to roll back to that old format, but we can optionally do a cleanup step to push change to remove that old format logic from the code base. So I think at Amazon, rolling back automatically is really a crucial part of how we let developers be hands-off with deployments, because they're able to trust that the pipeline is not only balancing safety and speed of their deployments and safely deploying them, but it's also going to automatically roll back as quickly as possible based on the metrics that they have set up in the pipeline. So rolling back automatically on those metrics-based alarms is really important for us, as well as letting deployments bake to minimize any impact, and then designing new changes for automatic rollback so the pipeline can always do its job. Let's now look at what happens before all these production deployments. What happens in the automatic pre-production testing? In that test stage of the pipeline, we need to build confidence that that change is correct and is not going to cause impact in production as much as we can before it goes to that first production one-box zonal production deployment. And at Amazon, we actually do this in a set of pre-production environments. So many pipelines have up to 3 or 4 pre-production environments where they're testing that change automatically in the pipeline. So let's look at what happens in each of these stages. Even before we deploy that change at all, the pipeline will automatically do the build, and it'll run unit tests and static analysis and linters, especially for things like infrastructure as code. And then it gets deployed to an alpha stage where we might run some limited functional tests just against that individual component that got deployed. And then in beta is when we start to do end-to-end testing. So integration tests are really important for us to ensure that the entire system continues to work as expected with this new change in this beta environment. So as an example, in this multi-tier application that has a front end, a back end, and a database, the integration tests might run against multiple levels of this multi-tier application. But especially it'll go against the front end, which calls the back end, which calls the database, to ensure that that entire call stack continues to function as expected before moving on to the next stage. And then Gamma is what we call as production-like as possible. Gamma uses all of the deployment strategies that our production stages use. So it has one boxes, it has monitoring canaries, it has auto rollback configuration at those same metric thresholds that production would use so that we catch any latency increases that this change introduced in Gamma before it goes to production. And again, it runs those same end-to-end integration tests against that production-like environment. One of the nice things about using all of our same deployment strategies that we use in production, like having a one box for Gamma, is that we actually get a little bit of backward compatibility testing in Gamma. We ensure that it's going to be safe and functional for there to be two code changes running side by side in production by deploying that change first to the Gamma 1 box and letting it bake there. So for a while, we have monitoring canaries running against this V2 and V1, both reading and writing the new format and the old format to ensure that we're staging those changes out the pipeline correctly. And then again, Gamma will run those same end-to-end integration tests when the pipelines deploy any of these components. So we're ensuring that, again, before we go to production, the whole stack is going to function as expected with this new change to an individual component. Some teams continue backward compatibility testing in a stage called Zeta. So Zeta ensures that that new code change is actually compatible with what's currently deployed in production, not just what's deployed in Gamma. So as an example, a Zeta front-end stage might call the production backend and the production database. And those end-to-end integration tests running in Zeta will feed test data into that Zeta front-end, which ends up storing test data in that production database. So we ensure that it's going to be safe for this change to move forward into production. So overall, automating this pre-production testing, again, lets developers be very hands-off from deployments. Once they push their code into the source code repository, pipeline triggers and all of this automated pre-production testing happens, and we gain confidence through testing in multiple pre-production environments before it goes to production. We do testing the system end-to-end for every change that goes through this system, and then testing in a pre-prod environment, Gamma, that is as production-like as possible. So overall, our approach to hands-off deployments is really only a few core deployment strategies, and our approach builds into how we construct our continuous delivery pipelines. We balance safety and speed of deployments in the pipelines with one boxes, rolling deployments, regional and zonal deployments, as well as deployment waves. We roll back automatically in the pipeline with metrics-based alarms and bake time. And then we automate all of that pre-production testing so that developers can be very hands-off from that change making its way into production. So going back to this typical continuous delivery pipeline for an AWS service team, it's still a little bit overwhelming to look at. The text is still very small. There's still a lot of steps going on here. But we can start to see some of those core deployment practices at play here. The deployment waves are there, deploying out to each region, some of them in parallel. They have one box stages. There are monitoring canaries and rolling deployments happening in those production stages. There are multiple pre-production environments deploying out to including Gamma with a production-like as possible deployment, as well as the source and the build at the start. And so when I started to learn about and really learn these core deployment practices, this wasn't quite as overwhelming when looking at these pipelines. So in this session, I was really only able to scratch the surface of how we construct our continuous delivery pipelines and all of the steps that they go through to safely and automatically deploy changes to production and let our developers be hands-off. But I've written a much longer and in detail article on the Amazon Builders Library about our approach to continuous delivery. And so you can check out that article on the Amazon Builders Library to go into much greater detail about how we do pipelines at Amazon. Thank you so much for watching this session. It's been really fun to be able to talk about what I've learned at Amazon about deploying safely to production and being able to be a hands-off deployment developer.